Hello and welcome everybody to another NI's ADAS and AD stories. My name is Daniel Riedlbauch. I'm the solutions marketer here in NI, focused on ADAS and autonomous drive validation tests. And today I have Mircea from Velodyne with me. Welcome, Mircea.
Thank you, Daniel. I appreciate your invitation and glad to be here.
Great to have you, Mircea. So please introduce yourself real quick, what you're doing at Velodyne.
Sure. I'm the Senior Vice President for Automotive Programs at Velodyne, which is another testimony to the great attention that we are allocating to anything that's autonomous vehicle or ADAS technology related. For various reasons. Certainly, one of the reasons is the great contribution that we can bring to enhancing these technologies from the safety perspective with LiDAR. And given our tremendous background in the field, we started about 10 years ago with the development of the first sensing suite on autonomous prototypes at the time. Certainly, we have continuity in this field, and again, it's one of our main business areas and main business focus in terms of priorities among the various applications. So we're very interested again in advancing ADAS and AV from the safety perspective.
Great. So definitely we will come back to that later. But as you also have already like a beautiful car in your background, I'm curious, like, okay, who is your favorite car manufacturer? And then also like, okay, what's the car that you're driving yourself?
Yeah, so being in the auto industry for more than 25 years, certainly my heart is with the OEMs that I worked for. I started my career with Daimler in Germany, so certainly I have a lot of respect for the company and their technology. I continued my career to Fiat Chrysler at the time. Again, a set of companies, including at the time also Ferrari and the big names Maserati and others that are a display of technology and advancements. And lately, before Velodyne, I was the head of engineering and quality at Hyundai, leading the North American efforts in these areas. And so I have a lot of interest, respect, and appreciation for the not only for the traditional Hyundai brand, but also for the Genesis brand, the equivalent of the luxury section in the Hyundai portfolio. And I was very honored to be part of the launch of that brand in the US. So those are, in a nutshell, my OEM, if you want, preferences for your question. But certainly I have a lot of other interests. As a car guy, I'm certainly interested in Porsche, and the hobby that I maintain as a car collector includes a Porsche 911, and we can talk more about that. But
definitely a nice classical car there. And as part of preparing for this interview, you also shared a nice story how you did an upgrade to your 911. So can you tell us a little bit more about that?
Yeah, it's actually not necessarily an upgrade to the vehicle itself. It was part of our research. So it had a very practical aspect to it. When we decided to pursue the execution of vehicle demonstrators for our directional LiDAR, one of the locations which certainly is extremely well suited for ADAS LiDAR placement within the vehicle is at the rear view mirror location behind the windscreen. So there is a sensor farm there, and there is a cutout of the infrared reflective coating in the windscreen, which allows certainly the sensing modalities to be performed unaffected, if you want, by the transmissivity of the windscreen. So the very practical aspect with my little collector car, 1986 Porsche 911, was related to the fact that at that time, windscreens didn't have IR coating. Therefore, the car was extremely well suited to understand how the LiDAR arrays will perform in terms of penetrating the windscreen and, as I said, going unaffected by either the inclination or reflectivity of the windscreen or any other potential coating. So it was a clean solution just to experiment with that a little bit. So very practical reasons for putting the LiDAR on the 911. It wasn't necessarily to bring the car to an ADAS level. It's a yeah. By definition, it's a driver's car, so that would be going against the very purpose of that vehicle.
Absolutely, and I think it's super exciting to hear that a Porsche 911 out of the 80s is actually helping and influencing future mobility and future safety. So I think that's interesting to hear that. Yeah, that's a great story.
Yeah. In fact, the story did culminate with us placing a LiDAR in the Tesla vehicle, in the Tesla S, which was displayed prominently at the IAA in Frankfurt in 2019, which was the last time when the show took place in Frankfurt, actually. As you know, this year it will take place in Munich, and we look forward to participate and display our technology in Munich in 2021, so in September.
Very good. Yeah, looking forward and to welcome you here then also in Munich and hopefully meet you in person there. Yeah, that's great to hear. Cool. So there's different sensor types out there, whether that's camera, radar, LiDAR, and so on and so forth, and they all have advantages and disadvantages. At the early stages of autonomous driving, everybody was gravitating already to like, oh, we have to bring all of these together because only then we will have best in class in terms of quality and ultimately safety for those things. But this also comes with the uptake of higher costs and higher complexity because we have a lot of systems that need to be synchronized together, and we have a lot of data that is going to be generated and so on and so forth. So I'm just curious, like, what's your perspective on something that I've been recently noticing, almost like a battle evolving amongst these different sensor types? So what's your take on that?
Yeah, so I think, as you said, in general, every single sensor modality has its own characteristics, and they can translate it into advantages. Our preference is to actually start with the use case of the vehicle, no matter what the vehicle is, because we're not talking only passenger cars. There are many other types of vehicles that we provide autonomy or driver assistance features to. And starting with the use cases allows you to actually highlight the benefits of one or another technology, very specific to that particular set of use cases. But there is also a kind of priority level that you have to assign in terms of the impact, again, no pun intended, of those technologies, because it's one thing to talk about driver convenience, as in park assist, as an example, and there is a completely different implication if you talk about something like PAEB, in case of, again, that feature making a difference literally in terms of life and death and number of lives affected by that. So convenience versus safety, you need to put a priority there, and then the use cases assigned to one or the other will be also prioritized accordingly, and then you can derive from that what is the technology that you agree, what is the must-have in the vehicle versus what is a nice-to-have type of technology. We certainly believe LiDAR has a lot of merits as the, if you want, technology that can become centric in the sensor suite. And again, we're open to augment that, and we did actually with other sensor modalities, colorization of the point cloud for better classification of the targets. Coupling this with thermal imaging is also a benefit. So there are many complementary aspects that we have considered. So we are not eliminating, one or another, but we certainly have a point of view regarding what technology should prevail in a specific use case, and we have data behind that. It's not certainly we manufacture LiDAR, but again, if you would look at the specific PAEB demonstration and testing that we provided actually as information also on our website, I think that would be a very compelling case for LiDAR use.
Great. No, makes perfect sense. So as a follow-up question, basically, so what are you at Velodyne then doing to help reduce the cost and also reduce the complexity of the technology?
Yeah, as the technology evolved over the last decade, in case of our LiDAR technology, and again, background and accumulating so much time on this is extremely beneficial because you literally go through generations and you go through phases.
Yeah.
The initial phases did involve a lot of manual assembly of our LiDARs. So craftsmanship and again, the direct influence of one or another operator on assembling the LiDAR played a very important role, not only in terms of cost, but also quality and so on. As we move now toward the latest generations and the products that we are launching or developing currently, we did incorporate what we call micro LiDAR array technology, which is essentially putting everything on a chip, everything pertaining to the laser diodes, the receivers, the APDs, the electronics processing the signal, the drivers for those diodes, and everything that again relates also to alignment, for instance, calibration. Everything is done automatically, so it takes out both the cost and quality component that certainly was addressed differently in the past. So everything, or system on a chip, is an idea that we promote very strongly in our manufacturing process. We developed this transmit-receive optical subassembly, which again incorporates all the elements that I mentioned before, and that becomes a kind of modular component that can be used in both rotational and directional sensors. So all our product lines benefit from that cost reduction and quality improvement initiative. So
that's perfect. And I mean, you were already connecting that. So costs reduction, complexity reduction, leading also at the same point in time also to higher quality, which ultimately means higher safety. And I think that's the critical portion as mentioned before. Do you have any questions for me?
Yeah, I mean, we're very excited to work with you and learn every day more about your capabilities, your company's capabilities, because as with all industries, modeling and simulation plays an extremely important role in the development of the product. And there are many approaches, right? But bottom line is, how do you, or what approach are you taking toward modeling the loop simulation? Is it a kind of more generic LiDAR model, or is it a very specific LiDAR model tailored to the very characteristics of one or another manufacturer, and then within their product range, picking exactly the characteristics of that particular product?
Yeah, great question, Mircea. And we're definitely using your Velodyne products there as well. So one of the most widest used, I would say, like the VLP-16 high resolution PUC that you have is also part of our suite there. And to your point, I mean, on the one hand side, it's about like creating models, physics-based models, and at the best case also validated models. And this is what we are actually doing through a recent acquisition. The company Monodrive is now part of NI, which creates models and then basically validates them against the real actual hardware. So really doing sensor characterization to make sure that we can then tie the models as close and fine-tune them as close to the actual real physical sensor out in the world. And that's not only true for LiDAR, but we're doing that also for radar, for cameras, and so on and so forth. And to your question, is that then going to be a generic model? Certainly not. It's going to be a sensor vendor and type specific model, so that you end up with, okay, I want to use the VLP-16, for example, as part of my modeling for my vehicle, and that is when you then can place that sensor into your simulator, basically. Mm-hmm.
Yeah, that's great. I mean, that's probably again the closest approach to reality, and that's what we want. That level of fidelity. You brought up a very interesting aspect, which is validating the simulation against the real hardware. I assume that you're going also through a set of environmental conditions that are relevant to the real world. Again, unfortunately, legislation is not supporting that entirely currently. But we as developers, and especially with the safety mindset that we have, we definitely need to look into, for instance, heavy rain conditions and distinguish between the benefits of one or another LiDAR or sensor modality from that perspective. The other obvious one is the lighting conditions. As I mentioned before, that is the first step actually, and it's the most obvious one that, again, we can introduce it now to augment the assessment of a sensor technology. So are you kind of going to this whole set of conditions, and can we help you with any specific information, if you want, on where the challenges reside? Because you have to somehow include those corner cases, and that would be beneficial for not only for us, because we will learn how to improve our technology, but certainly for the end user as well.
Absolutely. I think that's a great point there also, maybe to spark some further discussions around that. That's definitely going to be more than just what we can do with this interview right now. But yeah, absolutely. I mean, we're definitely looking to those things in terms of weather conditions, lighting conditions, then also making sure that we are bringing those things then into the simulator as well, also as physics-based parameters, so that these will have also a real impact then from the simulator back to the sensor as they are working with one another, basically. So that's absolutely something that is going to be necessary to make sure that we're bringing those puzzle pieces together.
It's exciting.
Absolutely. Maybe two more areas quickly for us before we're closing out here, where we are also using your technology, and typically, like I said, the VLP-16. So on our data record demonstration systems, we're also using the Velodyne LiDAR, like I said, widely used by many, and therefore also recognized for its quality. And another area where we are also using this is a sensor unit that we are using for ground truth extraction that also can be purchased, for example, from us, that is built out of 5 cameras plus a Velodyne LiDAR plus an IMU, basically, that can be mounted on a vehicle, so that you can then go out, record a set of miles, a set of scenarios, and through a technology called real to virtual, we have a semi-automatic way in translating that real-world recorded road data into virtual simulated data, basically, so that we can create a digital twin out of that we can run permutations in terms of weather, lighting conditions, and so on and so forth, pretty easily, again, reducing cost and effort for the end user, so that we can test against those different scenarios.
Yeah, that sounds extremely useful to, again, our common set of customers, both in the tier 1 space and OEM space. And I'm looking forward to strengthening this collaboration because, again, going through that whole set of scenarios is virtually impossible if you plan to do it, with the hardware and with the vehicle. In some cases, it's literally very difficult. So I think your value add to the whole process is tremendous by allowing that level of simulation. So.
And I think ultimately, as we have been talking about this before, it is all about safety and ultimately saving lives at the end of the day. And I think this is where we want to make sure that we are bringing together the best in class technology, also then working, for example, with you to make sure that at the end of the day, functionality in our vehicles is going to be safe, is going to be of the highest quality possible, to make sure that mobility becomes even a safer place for all of us to be.
That's been our priority because, again, the very definition of the features that we try to implement is related to enhancing safety. So we definitely need to prove that, again, contribution to safety, and that's been our priority.
Wonderful. Mircea, well, thank you very much for this interview. It has been a great pleasure talking through many of these topics with you. Just for everybody else who is watching this, feel free to leave your comments down below and let us know your feedback about this one. You can also, again, send me an email if you have follow-up questions, or find me simply on LinkedIn. And with that, I would like to say thank you for watching, and looking forward to see you on one of our next episodes of NI's ADAS and AD Stories. Thank you.
Thanks, Daniel, and thanks the audience. It's been a pleasure to be here. Thank you.